Welcome viewers, in this video we will see the construction of a DC machine. Subscribe the channel for more electrical videos. The soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic, construction of a DC machine. The DC machine is a device which convert electrical energy into mechanical energy or mechanical energy into electrical energy. So, while converting mechanical energy into electrical energy, it is called a DC generator. While converting electrical energy into mechanical energy, called a DC motor. So, the same machine can be used as either a generator or motor. So, there is no difference in the construction. The same machine is used for generator as well as a motor. So, that it is called a DC machine. So, the construction will always deal with the DC machine. So, that machine can be act as either generator or motor. So, the DC machine mainly having two main parts are available, the stationary part and rotating part. The stationary part is nothing but producing the magnetic flux. The stationary part is nothing but the coils are available, windings are available, so that will produce the magnetic flux. The rotating part is nothing but a armature. There also the coils are available. So, the conversion of electrical energy to mechanical energy or mechanical energy to electrical energy will be takes place in the armature, right. So, we have the detailed diagram available at the time, we can easily understand. So, the mainly we have stationary part, that is the coil, it will produce the magnetic flux. Rotating part called the armature, the conversion takes place in the armature. Now, we will go to the detailed diagram. So, this is the stationary part. This one is the stationary part called a yoke or frame. Here the coils are available. It's called a field windings. The stationary part, the coil what is available is called a field winding. So, the center what we have is the armature, rotating part. So, there also coils are available, right. So, this is the stationary part and this one rotating part. So, in the stationary part we will see first the yoke or frame is available, outer cover holding all these windings and armature, the outer frame is available. See, this is the pole core. Pole core is nothing but where we are going to place the coils. Here the pole core, this one pole shoe. So, this dotted line is nothing but a coils, field coils, right. So, this dotted lines, this shaded portion is the field winding. So, the field winding is placed in the pole core over the pole shoe. In that the coils are winded. So, here the 4 poles are available. These 2 pole is the N pole. These 2 are S pole. So, the direction of windings are given such a way that it will produce N pole, this will produce S pole, this will produce N pole and this will produce S pole, right. So, this field windings are available in the pole core over the pole shoe. So, while the excitation is given, it becomes the magnet, it's called a electromagnet. So, the stationary part is the field winding, it will produce the magnetic flux when the excitation is given. The poles are alternatively, N pole and S poles are available alternatively, right. Now, center what we have is the armature. What are the parts available? This is the armature core. Armature core means the place to put the windings is called a armature core. So, this dots is nothing but a armature winding. So, this is a cross sectional view. Normally, it is available in a cylindrical form. This armature core, this armature is available in a cylindrical form, right. So, this is a cross sectional view. So, here the armature core is available, over that armature windings are placed. So, this dotted line refers the armature winding, so rotating part. In order to supply the current or taking the current from the armature, what we have, the brush is available. That this is nothing but a brushes. This center portion is nothing but a commutator. This commutator is a device to supply the or take the current from the armature, right. It is a copper coils. This lines, this small line is nothing but the insulation between each and every segment, right. So, what we have here, the brush is available, that will use to collect or supply the current. Then this is the shaft, center portion is the shaft, and this is the commutator, right? So what we have, the commutator available at the center with the brushes in order to collect the current or supply the current to the armature, right? So we have stationary part, in that coils are available. When excitation, it becomes the electromagnet. At the center, the armature conductors available, and commutator with the brushes also available, right? So what will happen if it is motor or generator? We'll see that. So if it is motor, what we are, the mechanical energy is the, motor means electrical energy is the input, mechanical energy is the output. So the electrical energy is given to this armature. So the current is flowing through this armature. So it becomes a current carrying conductor. So in a motor, the electrical energy is the input, the mechanical energy is the output. So the supply is given to this armature. So the current is flowing through the armature coil. So it becomes a current carrying coil. Then excitation is given to this field winding, either self excited or separately excited. The topic is separately available. So excitation means to make this field winding into magnet. Now the supply is given to the armature coil, so it becomes a current carrying coil, and field windings are become a magnet. So what will happen? If a current carrying conductor placed in a magnetic field, it experiences a force. Experience a force means it will start rotate. So that is a motor. Electrical energy is given, current is flowing through the armature coil. So this current carrying coil placed in the magnetic field, so that it experiences a force, it will start rotate, right? So this is the magnetic field, is a current carrying coil. In case of generator, what is the input? Mechanical energy is the input. That is, we are going to rotate this armature. While rotating, it should produce the electrical energy. So the generator, mechanical energy is the input and electrical energy is the output. What is the mechanical energy? We are rotating this armature by using either another DC motor or prime mover. Prime mover means diesel generator or diesel engine or petrol engine. By using that, this armature is rotated. Now this field windings are excited. It is a magnet. It becomes a magnet. So what will happen in this generator? When a conductor cuts the magnetic field, an EMF is induced in the conductor. So this conductor is now rotating. Mechanical energy is given, rotating. This conductor is rotating in a magnetic field. Whenever the conductor cuts the magnetic field, then EMF is induced in the winding, in the coil. So that EMF is collected through the brushes. Through these brushes, the EMF, the generated voltage is collected, right? So in generator, mechanical energy is given, it start rotating. At that time, the fields are, magnetic field is available. So when a conductor cuts the magnetic field and EMF is induced, that EMF is taken from through this commutator, right? So this is the machine applicable for both motor as well as generator. Based on the input, it will act as either motor or generator, DC motor or DC generator, right? So the base, it is available at the bottom, the base is available. So it will hold the entire portion of the stationary part as well as rotating part. Now we'll go to the description of this one by one. First we will see the yoke or frame. So that is the thing, outermost part of the machine. So it will hold the entire part. So it is made up of cast iron for small machines and cast steel and silicon steel for large machines. So it's the outer cover that will hold the entire part. So it is made up of cast iron in case of small machine, or cast steel or silicon steel in case of large machine. What is the function of this yoke or frame? Act as a protecting cover for the machine. So it will hold all the material, all the windings, everything, and also to give the protection. It is fully covered. Poles are fixed to the yoke, so it serves as a mechanical support for the part. The poles are available. right? The winding, in order to put the winding, the poles are available. During the construction itself, they will decide the pole, either it is a 4 pole or 6 pole or 8 pole or 16 pole. Accordingly the construction is given. Over the pole we can place the winding. So it is the function is to hold the winding also. Carries magnetic flux produced by the part. So the poles available, when the winding is given, during excitation the flux is produced. So this yoke also carries the magnetic flux. This part of the flux also produced by, carried by this yoke. It's a function of this yoke or frame. Next we will go to the pole core and pole shoe. That is nothing but a field poles. Right. The field pole consists of pole core and pole shoe. First we will see pole core. So the pole core may be a solid structure or made of laminations. So this is the place to place the windings. This is called a pole core. It may be solid structure, but normally it is based on lamination. Like a thin sheets, like a notebook, that the sheets are available. Every sheet is laminated so that we can reduce the losses. So that it is given by lamination. Lamination reduces the eddy current loss. It is made up of cast iron or cast steel lamination, right? The solid structure is applicable for only few machines, but normally it is made up of the lamination. Each and every, it is a thin sheet available. N number of thin sheets are compressed together, but each sheet is laminated with the varnish so that the eddy current loss will be reduced. So what is the function? The field winding is wound around the pole core. So the winding is placed in the core. Core means, pole core means there is nothing but the place to put the windings, right? So it will carry the field winding. Then pole shoe. The pole shoe is made up of cast iron or cast steel. What is the function of this pole shoe? Support the field winding. Spread the flux in the air gap. Due to larger cross section area, they reduce the reluctance of the magnetic path. So it is a place to put the winding. So it will spread the fluxes in the air gap and also reduce the reluctance of a magnetic path. Now we'll go to the next part. Pole coils are field windings. Now we discuss pole core and pole shoe. So these windings are placed in the pole core or pole shoe. So it is nothing but it is a copper wire wound on a former and placed over the pole. I already discussed. Pole is the place to put the windings, right? So this copper wire is the winded and placed in the pole. The field windings are concealed in series with each other. All the field windings are connected together in opposite direction, so that it will produce N pole and S pole alternatively. It's not connected in a unique direction, unique connection. It is an opposite connection, so that the alternate poles are created. They wound in such a direction around the pole core so that alternate N and S poles are formed, right? So it is the connections are given such a way that it will produce N and S poles alternatively, right? So the pole core and pole shoe we discuss. In that pole core and pole shoe we are placing the field winding. What is the function of this field winding? When a current passes through this coil, they magnetize the pole, which produce the required magnetic flux. So the magnetic flux is produced in the field winding. When the excitation is given, it will produce the magnetic flux, right? Then we'll go to the rotating part, armature core. So far what we discuss is the stationary part. So in the armature core, it is a cylindrical shape. I already informed cylindrical shape. In the diagram what we seen is a cross sectional and is mounted on the shaft. It's a rotating part. So it is mounted on the shaft. It is a cylindrical shape. It is made of circular stamping, that is lamination. It is not a single piece, it is a lamination. N number of sheets are available. Each and every sheet is laminated and compressed together. It is made up of silicon steel insulated from each other. So each and every sheet is insulated so that we can reduce the losses. The laminated structure reduce the eddy current loss. Eddy current loss we'll see later. So it will reduce the eddy current loss. It has slots on the outer periphery to house the armature winding. The slots called a pole. The slots will be there. Over the slot the armature winding can be placed. It is made of silicon steel to reduce hysteresis losses. Right? In order to reduce the hysteresis losses, it is made up of silicon steel. So what is the function of this armature core? To have armature winding, to place the armature winding, to rotate the armature winding in the magnetic field, produce very low reluctance path. Right? So this armature core is a place to put the armature winding and thereby rotating the armature also. Now we will go to the next topic. Now we will see the armature winding. So we discussed armature. In that armature this winding is placed. That is, it is a copper wire wound on a former and placed in the slot. So copper wire is placed in that slot so that it acts as a conductor. So in this winding there are two types available, lap winding and wave winding. There are two types are available. We will see this one by one. So in this lap winding, the number of parallel path equal to number of pole, that is A equal to P. What is number of parallel path? There are n number of poles available mean n number of parallel path will be there. 4 poles available mean 4 paths will be available. The number of brushes is required to the number of poles. Used for high current, low voltage applications. Normally used for generator of capacity more than 500 amperes. Now we will see what is this winding, how it is connected. So this is a coil. These coils are available. This is nothing but a commutator. There are n number of segments are available. So in this lap winding, the number of poles equal to number of parallel paths. So 4 poles available means 4 paths will be available. See this first coil is start from here and it is connected to the second segment. First coil starts here. S1 is starts and go with the finishing F1. It is a start and finish. S1 means start, the first starting. F is the first finishing. So it starts at the coil starts at the first slot of the commutator and finish at the second slot of the commutator. The second coil start from second slot of the commutator and then finish at the third slot of the commutator. So like that the windings are placed. So there are n number of windings are available. Number of parallel path equal to number of poles. Like that it is going, lap winding, right? So each and every coil is closed, right? Start, end, like that it will go. Start from 1, end with 2. Start with 2 and end with 3. Like that it will go. Start in one slot, finish in the second slot. Similarly, start in the second slot, finish in the third slot. Like that it will go. We have the one more winding, wave winding. So another type of winding is wave winding. Here number of parallel path equal to 2 irrespective of the number of poles. So only 2 parallel paths are available, right? Start from one point, it will complete all the poles. Number of brushes is always required is only 2. Only 2 brushes are required. Start, end, like that. Used for low current, high voltage applications. Preferred for generator of capacity less than 500 amperes. So the previous one lap winding used for more than 500 amperes. This one used for less than 500 amperes. Now we will see the connection. In wave winding, one end part of coil is allied to the beginning of end part of another coil. So in the previous method, each and every coil having starting and ending. But here, one end of the one coil is the beginning of the another coil. So the same, only one path, only 2 paths available. So we start with one coil, it goes to the beginning of the next coil. Has the similar polarity like the first coil. These coils are allied in a wave form and it is called as wave winding. Like a wave, it will go So that it is called a wave winding. We'll see the diagram so that you're able to understand easily. So this is the commutator segments 1, 2, 3. See here, the coil 1 start at the first segment. It will go like this. It will keep on, it is rotate, keep on, it is placed, and end with the, after some places it is end with the finishing S1. Right. So if it is n number of, if 5 poles are available, 5 times it will go and end with 1 point. So starting and ending is S1 and F1 is like a wave, it will goes. But in previous case, each and every coil is completed. Right, start and end with the next slot immediately. Start 1 means it will end with the second slot immediately. Start with the second slot means end with the third slot immediately in the previous case. But here you start here, if 6 poles are available mean 6 times it will go like a wave and finish at the another point. Right. In previous case, 1 pole is completed entirely, then only it will go to the second pole, then third pole. But here all 6 poles are completed in a one, like a wave, then it will complete. Right. So that is called a wave winding. Right. I think you were able to understand. Lap winding means each and every pole is completed, then it will go to the next pole. Here all poles are covered by the coil. Right. So these are segments. Now we'll go to the next one, commutator. How this commutator collect the current or supply the current to the armature winding. A commutator converts alternating voltage into direct voltage. It is cylindrical structure. It is built of segments made of hard drawn copper. The segments are separated from each other by microstrip. Is separated by microstrip. These segments are connected to the winding. Right. So we already discussed that. See this diagram. So this is the segment. N number of segments are available. So it's made up of copper and is separated by the mica strip. So there is no connection between these two segments. Right. Segments are made up of copper separated by the microstrip. So it will use to convert alternating to direct current, and one more diagram is available. So I already told it's a cylindrical form. Right. So this is nothing but commutator segment with hard drawn copper to reduce wear and tear. So this is nothing but a copper segments. So these lines is nothing but a mica insulation. Each and every segments are insulated by the mica. There is no connection, there is no short circuit. Right. So that the coil, if suppose if 12 poles are available, mean there will be 12 segments will be available. Each and every pole is supply is given separately from the segment. Right. And also it is insulated by the mica insulation. Now we'll see what is the function of this commutator. The commutator function is collect the current from the armature winding, convert the alternating current into unidirectional current. It produces unidirectional torque in the motor. Right. So it will collect the current, also supply the current. In case of motor, it will supply the current. In case of generator, it will collect the current and also convert into unidirectional current. Right. So the commutator is the important part to collect or supply the current to the armature. Now we'll see the another next topic, brush gear. To collect the current from the commutator and give it to the load. So the brushes are available, copper brushes. Right. The brush gear consists of brushes and brush holder. Because it's rotating part, the brush is available, so it will continuously collect the current from the commutator, that is from the copper segment. So what is brush? The brush are stationary and rest on the surface of the commutator. It is made up of copper, graphite or carbon because it is continuously rotating. So wear and tear will be available. So it is made up of either copper, graphite or carbon. What is brush holder? The brush holder hold the position by means of the brushes are hold in position by means of brush holders. These brushes are held by these brush holders, right? So the commutator is the place to supply the current or take the current from the armature. That is done through these brushes. The current is taken or given by the brushes. So finally what we have is the shaft. So all rotating parts are mounted on the shaft, that is armature winding, brush, everything are mounted. So it is a rotating part. So in this video we discuss about the construction of a machine, DC machine. That is the same machine used as either generator or motor. Accordingly, what are the parts available we discussed, stationary part and this rotating part. Subscribe this channel for more videos. The material is available in the link. The link is given in the description box. The other topics of the DC machine also available in the description box. Thank you.